actually, I skipped the whole thing I wanted to do. I would like for you to do this problem. I'm not going to remind you how. I want to see what you remember and what you try. And then we'll talk about it and use it to lead us into today's lesson. So take a few minutes, try to remember how to solve 2 to the x equals 16. So let's say you're looking at this problem and you feel like it's an exponential and you can rewrite it as a log to do lasso. You might try this. You'd say log base 2 of 16 equals x. And that's not really wrong, but it's not a great answer because what does log base 2 of 16 mean? It's not like easily accessible to your brain. It would be better if you first rewrote the 16 with a base of 2. And what is that? It's 2 to the what? 4. And the reason why that's better is because now it's really easy to see what the solution is. What does x have to equal? 4, right? Once you get the bases the same, you set the exponents equal, and you have x equals 4. And so real quickly, before I talk about this next thing that says any ideas, blah, 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 before I talk about that, I just want to review the methods we've already learned. The rewriting the base is the first thing we learned. You shouldn't do lasso if you can do this instead, because it gives you a better answer, better form. The lasso comes in when you have an equation where you can't rewrite the base. Like if I had, instead of 2 to the x equals 16, if I had 2 to the x equals 9, I can't rewrite 9 to have a base of 2. So that's when I would lasso. And then we would have log, and then that would be our answer. The method we learned yesterday is for when there's multiple logs in an equation. But it wasn't just multiple logs. There was an extra thing in yesterday's equation that's not going to be in today's. Do you remember what was from our notes yesterday? It said get all the logs on one side and the what on the other. Constant, very good. So yesterday's method was for multiple logs and a constant. Because what we would do there is condense the logs so that you only had one on one side. I don't know. And then you had a constant on the other. And the reason why we would do that is so we could lasso. Then we would lasso. And we would solve. Today's method is this. We have multiple logs and no constant. And that's another method. And this is where I want to pick up here. Okay, at this thing that says any ideas. So right here, from that example problem, once we got the bases the same, we dropped them. And we said x equals 4. Well, on this thing right here, this log base 2, x plus 3 equals log of base 2 of 14, the logs are the same. Any ideas what we can do here? That's kind of a lot like what we did here. What? Drop them. We drop the logs. So there's no constant here, right, to mess anything up. If log of this equals log of this, then it stands to reason that those two purple boxes must be equal to each other because it's an equation. So this is the basic idea for today. Once you have one log on each side, they have the same base and they're equal, then you just drop the logs and set their values equal to each other and solve. Because to solve here, you would subtract 3, you would get 11. And if you were to plug that back in, you'd have log 2 of 11 plus 3. What is 11 plus 3? It's 14. So you'd have log of 14 equals log of 14, and that would be true. Okay. So today's method is for when you have multiple logs and no constant. Your goal is to just drop the logs off completely. There will be no lassoing involved. I'm going to talk about all that as we do it. First problem. How many logs do you see? 3. How many constants do you see? 0, right? There's no constant. So this is today's new method. Which side has multiple logs? The left. And what we're going to do there is our condensing properties, right? We're going to condense it into one, like we were practicing in the Kahoot. This subtraction right here means when I condense into one log, am I going to be multiplying or dividing? Dividing. So I'm going to make a fraction. And which thing goes on top? The 6. So now I have natural log of something equals natural log of something. That's exactly what I wanted. What can I do now with those ln's? Drop them. And then set the values that you're taking the log of, set them equal to each other. Now that all right there was our new method for today. Okay. What comes next is just all the algebra skills that we have. Like yesterday's homework, today's lesson, and tonight's homework, once you get to the solving part, they're all kind of different. They all have their own personalities, and you're going to have to think through each one separately. Okay. So for this problem right here, what do you feel like we could do to get started solving for R? Multiply both sides by 5 minus R. That's how I would start, because I like to get rid of the denominator as soon as possible. So I'm going to do that. Multiply both sides by 5 minus R. I like mixing red and purple. It makes me happy. So the 5 minus R's cancel, leaving me 6 on the left. And here's the thing about what's on the right. It really looks like, the way I've written it, that I just need to distribute the 2 and then combine like terms. That's if I was being sloppy with my math. But that 5 minus R isn't just times the 2, right? It's actually times everything on that right-hand side. So this is really a FOIL problem. Okay, not just distributing the 2. So take a second and FOIL the right-hand side of your equation. 5R minus R squared plus 10 minus 2R. How'd I do? Are we agreed? Did I do well? All right. So some more hints here, okay? Trying to go through your thought process. So you're looking at this. What's something you could do next to move the problem forward? Yes. Combine like terms, right? What combines on the right-hand side? Those. So you could do that. Negative R squared plus 3R plus 10. Now, if you're looking at it trying to figure out what to do next, you might see the squared and think eventually I'm going to have to square root. And so I need to get everything to one side so I can do that. But that will fail you because this term right here has an R in it. Okay? The only time you can square root both sides is if you only have the squared term and constants everywhere else. So instead of square rooting here, when you have a problem with a squared term and a exponent of 1, so you have the R squared and the R, you're going to have to factor. And in order to factor, you have to get it equal to 0. So if I need that, what should be my next step? Subtract the 6. So that will give me 0 equals negative R squared plus 3R plus 4. But what don't I like about that? Before I can factor, I need to take care of what? The negative in front of the R squared. Okay. So divide everything by -1. Or multiply both sides by negative. Oh wait, I forgot I was mixing with red. Hold on. So 0 equals positive r squared minus 3r minus 4. And so now you would factor what multiplies to -4, adds to -3. You go ahead and finish the problem out. Take a moment and do that. So -4 and 1, dividing by the a if you're doing swing method, doesn't change anything. You'll get the same thing if you did grouping. Several of you stopped right here. So we want to actually go through and solve. So these are my factors. How do I use them to get my solutions? I set them equal to 0 and then solve both of them, right? So set it equal to 0, set that one equal to 0, and you get r equals 4 and -1. Why is that a big fat maybe? Because you have to plug it back in, check them both out. A lot of times I'll see students see that one of their solutions is negative and automatically just say, oh, I can't have a negative solution. She said it can't be negative, but that's not right, okay? The solution can be negative. What can't be negative is if it makes any of the logs negative in the original problem. So you have to go plug them all in. So we're checking 4 and -1. You don't have to plug it in here because why? It's a constant, right? There's no r. There's no place to plug it in. That's always going to be positive and not 0 because it's 6. So when I put -1 in for the r here, I've got 5 minus r, which is -1. And what does minus and negative become? Positive. So that's okay. -1 checks out there. So then we just need to see if it checks out in the other log. Does it check out? Yes, because that's +1, so it's good there. And then we check 4. 5 minus 4 checks because it's +1, and 4 plus 2 checks because it stays positive. So we have no extraneous solutions. Okay, or if you want squiggly wigglies, it looks like this. For set notation, because it's a list of numbers. Questions about that problem? Notice there's no lasso. There's no lasso because there was no what in the original problem? Constant. There was no constant. So you're not going to lasso. Okay, let's look at this one. How many logs do you see? How many constants do you see? Correct. Very good. So when you don't see a constant, your goal is to get log equals log so you can drop the logs. Okay, I want you to try this whole problem by yourself. It's got a weird answer, so if you're getting a weird answer, trust yourself a little bit and just go with it. But it's nothing we can't handle. You all began correctly. You compressed on the left using what? Multiplication or division? Multiplication. So this became log of 1 minus x times x equals log of x plus 4. There's no constants anywhere. So once you have log of something equals log of something, you just get rid of the logs and bring down their values. And the parentheses have been causing students confusion today. I think they feel like the things are grouped together and maybe they want to, I saw some students earlier today trying to divide by the 1 minus x and stuff. Don't worry about that. That's kind of just overthinking the problem. On the right-hand side, parentheses x plus 4, since nothing's being added or multiplied outside, it's really just the same as this with no parentheses. And then on the left-hand side, you can just distribute that x. So 1 times x is x minus x times x, which is x squared. So here's where we are. And then a lot of students all day just stopping here because they're not exactly sure what to do next. Because it gets weird. Like, what's the first weird thing that happens next? What cancels out? The x's do. So you might have been thinking, oh, there's an x squared and an x. She said I'm going to have the factor if that happens. But hold on, because those cancel. And then I've got the second weird thing. Negative x squared equals 4. So then you might be thinking, okay, she said when there's a squared and a constant, then I can square root. But I have to take care of this first. How do I take care of that negative before I can square root? Right, divide it off or multiply it off, whichever you want. And so then that gives me x squared equals negative 4. And this is something I want to talk about, okay? A lot of you did this, square rooted both sides, and said x equals positive negative 2i. Now that's a thing, okay? But it's not a thing for logs, because if you take 2i and plug it back into the original problem, we don't take log of 2i, of imaginary numbers. Log is defined only in the real number system. Like, remember when we graphed it? There's no part of the domain that's imaginary number. This is only real numbers. So instead of plus or minus 2i, which isn't bad math, I mean, that was correct math, the actual preferred answer I want here is this. No real solution. There's an imaginary solution, but there's no real solution, because we're not going to take log of an imaginary number. It's not defined that way. It's not the correct universe. And the last thing, what time do we get out of here? 25? We have so much time. 20? Oh, yeah, it's not a flex day. Okay. Oh, we still have a lot of time. The last thing I want to do on the back, we're not going to work out all the whole things. I just want to, these are mixed problems. They're not over today's lesson. I just want to sort of give you some time to think about them and how you would set them up correctly. And then I have them all worked out. You're welcome to take a picture before you leave after we talk about them. But really, I'm more interested in you just thinking about it for a bit. So on this first one, I want you to think about what all the different methods we have and how you would use them. I'll write the methods up here while you think about it. We had rewrite bases. We had lasso. Multiple logs and a constant. That was yesterday. And then multiple logs, no constant. These are our 4 things. What do you feel like you would try first with this problem? Lasso? Why wouldn't you try rewrite basis first? Any good reasons? I would try rewrite basis first. If you were to try to rewrite bases, what base would you want on that right-hand side? 3. So you could start doing a factor tree, see how many 3s go in there. But you'd realize real fast that 3 does not go into 427. And so at this part of your thinking, then you would say, okay, that didn't work, now I do lasso. Okay. And the reason why I'm going through all that trouble is because I think that's, when you get to your test next week, if your first method doesn't work, try something else. Don't feel like you're stupid or that you just quit or that you can't figure it out. It's okay to just try something else. You got 4 things you got to figure out. And so the first one didn't work. So then you can go to lasso. It's not multiple logs because there aren't any logs. So you would lasso. You would rewrite it as a log. And you would continue solving. Okay. This is that problem, that kind of problem where we leave it in exact form. And it looks funky. but it's not too bad. It's not really hard. Okay, so remember those 4 methods and look at this one. Why is this problem not a rewrite with the same base problem? It's not. What can you not rewrite with a base of E? 4. So you automatically can't do that one. So it's basically a lasso problem, but what would you have to do before you can lasso? Because I see 2 bases. How would you lasso if there's 2 bases? How would you get it down to 1 base? It's an exponent rule. Add. You would add the exponents. And then from here you could lasso. There's just a tiny bit more to do, but it's not hard. All right, here's this method. Now, this is one of the multiple logs. Your thing you need to ask yourself is it multiple logs with a constant or without? With or without? With. So if it's with a constant, it's when this is where you compress to 1 log, and you have some stuff in here, equals 2. And then what would you do after this? You would lasso, okay? The reason why it's very important to notice if it has a constant or not is the constant allows you to lasso. Today's problems with no constant is where you drop the logs. There is no lassoing involved. Is this a lasso problem or not? It is. What makes this you're eventually going to have to lasso? How do you know? There's a constant, okay? And again, I have these all worked out in my notes up here. If you would like a picture, I'll try to also remember to put it in my Google Classroom. Let me give you your homework.